Welcome to lesson number 2, factoring polynomial expressions. We're going to begin with looking at these algebra tiles shown. And so if I have this set of algebra tiles shown, we want to write the polynomial expression that's represented by these. So this tile here is an x squared tile. These represent x's and these represent 1's. So I have 1, 2, 3, 4, 5, 6x, all positive. And then I have 8 1's, so plus 8. So the algebra tiles can also be rearranged into a rectangular form as we see here. We want to write an expression for the length. So from here to here. So this point to this point, we would have for the length, we would have x squared, x plus 1, 2, 3, 4. And for the width of the rectangle, we have x plus 2, 1, 2, x plus 2, or x and 4, and x and 2. So you want to write the area of the rectangle as a product of two binomials. So x plus 4 times x plus 2 is equal to our area, so length times width. And in expanded form, if we were to FOIL this, we have x times x is x squared. X times 2 is positive 2x. 4 times x is positive 4x. And 4 times 2 is positive 8. Simplified, we would write this as x squared plus 6x plus 8. Same thing that we have above. So this kind of shows us a method for factoring a trinomial as well. If we take the area, the dimensions of the area of a trinomial, we can get it into a binomial, two binomials. Now we want to write the polynomial expression, which is represented by these algebra tiles. So we have x squared, 1, 2, 3, 4, 5, plus 5x, and then plus 1, 2, 3, 4. And we want to arrange our algebra tiles into a rectangle, and then we want to write an expression for the length and width of the rectangle. So we're going to arrange it something like this. I got my x squared here, and then I have 1, 2, 3, 4, 5. So I can arrange it like this. 1, 2, 1, 2, 3. Now if we look at we only have 4 1's, and so if I were to place my 1's like this, we're gonna be short 1. And so a better way to do this is to go like this. So 1 there, and 1, 2, 3, 4, and then we have our 4 1's. So we want to use the results above to express our polynomial in factored form. Well, I have x plus 1, or if I look at it this way, x plus 1 and x plus 4. So x plus 1 times x plus 4. Now, with this investigation, we're going to be looking at factoring trinomials by inspection. So this is a way that we can factor trinomials without using algebra tiles, but looking at the last term and the middle term. So before we begin, we just want to expand these, just like what was shown above. So using our FOIL method, we want to expand these. And I'm just going to do a few of them, not all of them. So here I'll have x squared. So if I FOIL x squared plus 3x plus 3x plus 9 is equal to x squared plus 6x plus 9. Here I have x squared plus 7x plus x plus 7 would be x squared plus 8x plus 7. And then I'll do one of these ones with negatives. X squared minus 2x minus 5x plus 10 is equal to x squared minus 7x plus 10. And then I'll do this last one. I have x squared minus 6x minus 8x minus 48 is equal to x squared. And hold on, one of these is positive, so x squared minus 6x, this is positive, plus 8x, would be x squared plus 2x minus 48. Now we're going to look at a pattern that emerges. So consider the expansion x plus p times x plus q, where this is equal to x squared plus bx plus c. In each of the examples above, what is the connection between the value of b, so that's my b values, I'm just going to highlight using pink. So my values of b are here, 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 and here. And the values, so the values of b and the values of p and q. And so my values of p and q, I'm going to highlight in yellow. So here's p and q, p and q, p and q, p and q. So if I look at the value of b here, or let's go at the beginning, 6. Here's my value of b, and here's my value of q and p. So p and q, 3 plus 3 is equal to 6. 1 plus 7 is equal to 8. Negative 5 plus negative 2 is equal to negative 7. And positive 8 plus negative 6 is equal to positive 2. So b is equal to p plus q. Now the value of c and the value of p and q. So I'm going to highlight my value of c in green. So here's c, and that is the last term of all of these. So let's see that pattern. So p and q, 3 and 3 and 9. So 3 times 3 equals 9. 1 and 7 and 7. 1 times 7 equals 7. Negative 5 and negative 2, positive 10. So negative 5 times negative 5. Negative 2 is equal to positive 10. And positive 8 times negative 6 is equal to negative 48. So c is equal to p times q. Factoring x squared plus bx plus c by inspection, that's actually what we just did. So in order to factor this by inspection, we need to find two integers which have a product equal to c and a sum equal to b. And if no two such integers exist, then the polynomial cannot be factored. So as an example, in order to factor x squared plus 8x plus 12, we need to find two numbers which multiply to 12 and add to 8. So they multiply to give me that last term and add to give me this middle term. That being said, in order to factor x squared minus 13x plus 12, we need to find two numbers which multiply to 12 and add to negative 13. And so in this class example number 4, we're going to practice that. So this first one's done for us. And let's move on to the second one. So we want to have a sum of 9. So they need to add to give me 9, but they need to multiply to give me 20. So if I start with 1 times 20, that obviously won't work because they can't have a sum of 9. So let's try 2 times 10. Well, 2 times 10 we cannot combine to give me 9. How about 3? 3 doesn't go into 20 evenly. So how about 4 and 5? Well, 4 times 5 is 20. 4 plus 5 is 9. So that checks out. So we need to have a product of 4 and a sum of 4. So we have 1 and 4. Well, 1 times 4 is 4, but 1 plus 4 is 5. So it can't be that. How about 2? Well, 2 times 2 is 4, and 2 plus 2 is 4. That also checks out. A product of 18. Well, 1 times 18 does not add to give me negative 9. 2 times 9 cannot add to give me negative 9. But how about negative 3 and negative 6? Negative 3 times negative 6 is equal to positive 18. Negative 3 plus negative 6 equals negative 9. And then I'll just do this last one. We have to have a product of 48 and a sum of negative 26. Well, let's see, 8 and 6 is equal to 48, but there's no way we can combine those to get negative 26. But 2 and 24 is 48, and negative 2 and negative 24, when added, is negative 26, and multiplied is positive 48. Now we're using factoring trinomial. We're going to factor these trinomials where possible. So using inspection, so that that method we were just using, we're going to look at how to factor something like this. So this is where I'm going to introduce you to a little method that is helpful. So this x represents multiplying, and this addition sign is obviously adding or finding a sum. And so here we need to have a sum of, or sorry, a product of 12 and a sum of 8. And so here I'm just going to, it may be obvious to what the factors are, but I'm just going to start as if it weren't obvious. So first of all, 1 times 12 multiplies to give me 12, but 1 plus 12 does not multiply to give me, or add to give me 8, so it can't be that one. So I go down my list of factors. How about 2 times 6? Well, 2 times 6 is 12, and 2 plus 6 is 8. So those are the factors that I'm going to use. And the way we would factor this is we would factor it as a binomial where 2 and 6 are my factors. So positive 2 and positive 6. One way to ensure that we are factoring it correctly is if we were to FOIL it again. So foiling my factored factors, we need to make sure that we are getting our original trinomial of x squared plus 8x plus 12. So I'll do another one, y squared plus 3y plus 4. So multiply to give me 4, add to give me 3. Well, we have 1 and 4. Now, there's different ways we can combine 1 and 4 to give me positive 4, and to give me positive 3 is another story. So if I were to choose negative 1 and negative 4, then that can be positive 4, but that's going to be a negative 5. And so there's actually nothing that can factor to give me this. So we would say that this is not factorable. And then we could try, let's try this one here. So multiply to give me positive 12, add to give me negative 13. So let's start with 1, and since this is negative, we'll try negative 1 and negative 12. Negative 1 plus negative 12. Well, this gives me negative 13, and that gives me positive 12. So these are my factors, negative 1 and negative 12. So when we plug this in, we're going to have x minus 1, x minus 12. And this last example, if I were to factor the polynomial expressions by first removing a common factor, so if I look at 4x squared, negative 32x, and 48, I can take out the 4 out of all of them. So that would leave us with 4x squared minus 4 out of 32 is 8x, and 4 out of 48 is 16. Now I can factor 8x and 16 by saying, okay, well, what multiplies to give me 16 but adds to give me negative 8? We have negative 4 and negative 4, and negative 4 plus negative 4. So we would have 4x minus 4, x minus 4. Or we could also say 4x minus 4 squared.